So this is the great angle chase. I'll try to do it in one video, but I may break it into two, depends how quickly we go through it. So the first thing I noticed when I spotted some angles on here was this here. Now, if you have a line going through the center of the circle, you instantly know you're going to get some right angle triangles appearing. So that's what I did first. I noticed that the right angles are going to be here, here, and here. So that's going to help later, I think, and that's going to be using this fact. The other things are going to be trying to use the 35. So where else is 35 going to appear? Well, it subtends from the line UT, but this is the only angle that subtends from there. So I'm not going to be able to use that at the moment. What about the 25 degrees? Well, this comes from the alternate segment theorem, and the triangle that 25 comes from is here. So that must be 25, that corner. This is then the remainder of 90, which is 65. How else am I going to use these angles? Well, the 25, does that appear in any other angle? Well, it subtends from this line. Are there any other angles that subtend from that on the outside? No, there are not. What about the 65 degrees? That subtends from the chord QS. Are there any other angles that subtend from this? Yes, there is. It's this one here, which is 65 degrees. So, is there another angle that comes from here? No, there's only that one, I think. Now, another thing which is quite interesting to note is these things, and that means that they're both the same length. Now, if you've got two lengths that are the same that come off the diameter, this creates a quite interesting shape. If this is the same length as that, it turns out that we get a set of parallel lines here. So we know that this angle here, that line is going to be parallel to this one, and that's really going to help us, I think, with Z angles or alternate angles. So if we know that this is 25 and 65, in fact these add up to 90 degrees, and therefore we know that the other side of this is going to add up to 90 as well. I'm not sure how to use that yet, but maybe I'll just put that here so we know that that's a 90 degree angle. Okay. So we've got 90 degree angles all over the place, and we've got 25 degrees. Maybe we can use these. We know we got the 35 degrees here and the 25 here, so we can work out what these angles are. So the 35 and the 25 add up to 60. This must be 120 degrees, and this adds up to a straight line, must be 60, and we have the same the other side, so these are going to be 60 and 120. So that's quite nice to get them out of the way and sorted. We might be able to notice here that we have a triangle, small triangle there. Alternatively, a big triangle, we could do the 35 with the 90 here. So 90 minus 35 is going to be 55 degrees. And that means that this one's also 55. And from the same thing we did over here, we can work out what the top angle and the bottom angle is from that. So 180 minus 55, 180 minus 50 is 130, so it's 125. Great, so we're getting somewhere here. This triangle here has the right angle in it, and so if that's 55, this would be adding up to 90 degrees, which would make 35 degrees. Now, I'll notice that 35 actually subtends from the chord UT, and I didn't spot that originally, but look, that one's 35. That angle there, I could have written 35 straight away. I just didn't spot it, but now I know it's there, and it's fine. It works. Okay. What else do I have? I'm looking for different sizes of triangles, big ones and small ones. And this will conclude part 1 of the video. I'm going to go in part 2 when I've given it some thought.